We will be presenting Markov chain methods for generating video captions. This work is a joint effort by Joshua Williams, Leslie Rice, and Helen Jiang. Describing what happens in a video in a coherent sentence is easy for humans but difficult for machines. Currently, automated video captioning methods are challenging and require a lot of resources and computation power. For our project, we attempt to simplify this problem by sampling frames from videos and treating the problem as an image captioning task instead, where we caption each frame intelligently and combine these captions together using techniques from story generation. This is a quick summary of our approach to tackling this newly formed task of image captioning. We will now go through each step with more detail. To do this, we use the Structural Similarity Index, or SSIM, to measure the perceptual difference between two images. Here we show the SSIM score for the sequence of images below. The first and second frames are less perceptually similar, so we caption both frames. However, the second and third frames are perceptually identical enough, so we do not caption the third frame. After we have the frames that are perceptually different from each other, we treat them as images that we want to caption. We use a standard image captioning model to create these captions. Our model is pre-trained on the COCO dataset with an encoder-decoder framework. The encoder is a CNN called ResNet 152 that takes in the video frame and is pre-trained on the ImageNet dataset. The decoder is an LSTM that outputs the caption.
Once we have each caption, we use a spacey natural language processor to generate an event tuple of the subject, verb, object, and modifier of the caption. Using these events, we can decrease the dimensionality of each caption into a more manageable form for our model. Once we have each event, we pass the events into a sequence model, which we're using as an MCMC. We assume a known distribution as a random Gaussian noise applied to the encoded state of the sequence-to-sequence model, and our proposed distribution is the joint probability of the decoder's output. Our acceptance criteria is currently this joint probability. By applying random noise in the sequence-to-sequence model, we can generate multiple distinct sentences from the same label.
We test our method on the YouTube clips dataset, which consists of around 2,000 short video clips from YouTube. Our sequence-to-sequence model is trained on the Microsoft COCO dataset. The acceptance criteria ends up being extremely small, all ranging around 10 to the negative 45, making it almost impossible for any caption to be accepted. Because of this, our output captions are handpicked. Since our dataset does not contain any examples with 2 or more sentences per caption, we cannot train the model to combine sentences, so we require a second sequence model to combine them. Here is an example of an input video and its human-labeled captions from the YouTube clips dataset. Here are examples of outputs from the image captioning model and the event tuples generated from those captions using the spacey natural language processor. For example, in the bottom left, the caption is a man sitting on the bench next to a tree, which then gets converted to an event of man sitting bench tree next. Here are some examples of what our MCMC, the sequence-to-sequence model, outputs given an event tuple. As you can see, a lot of these examples are almost coherent but doesn't quite make logical sense, like a man sitting on a bench next to a bench. In conclusion, our project found that we can extract information from images and output relevant captions with a sequence-to-sequence model implemented as an MCMC. There are a few limitations with our approach that in the future we would like to improve on. Some limitations include how limited our dataset is. The videos from the YouTube clips dataset are very short. The COCO captions are also very short, which prevents us from captioning each video with more than one sentence. Thank you.